So we're going to start this today, and we're going to finish this tomorrow, okay? So what I want you to do first is let's talk about the three main things when it talks about motion. All right, so the first thing is we've got position. And for position, we use x of t most of the time, and that's a horizontal distance from the origin. All right, but sometimes we use a vertical, and that's y of t. All right, in previous classes, you might have used s of t. We don't ever use that in calculus. It's always x or y because it's the difference between horizontal and vertical. All right, so velocity we know is v of t, and how is velocity related to position?
It's the derivative.
It's the derivative. So I'm going to go ahead and write x prime of t, and if you wanted to, you could write y prime. I'm going to just stick kind of with x for right now, because that's how it is on 90% of the problems. And then the last thing here would be acceleration. And so acceleration, we always use a of t, and acceleration would be the derivative of velocity, and it would be the second derivative of position. So we've already reviewed in our AP review about f prime, f double prime, and the whole increasing, decreasing, positive, negative, rate of change, blah, 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 okay? So I want you to look through 1 through 10. There should be 10 right here. And I want you to see how many of these blanks you can fill out in a minute. If you don't know one, skip it and go to the next. Okay, let's go over these. So what does initially mean? What equals 0 for initially? T. Good. It's like starting your stopwatch. Okay, at the origin has to do with location, so what equals x or y, depending on which one you're dealing with. And then at rest, not moving, what equals 0? The v, the velocity. Okay, the rest of these should have all been words. So if the velocity of the particle is blank, then the particle is moving to the left. Negative. Good. The next one goes very similar. It's very similar. Velocity is positive, then the particle is moving to the right. Again, if we were dealing with y, we would be doing up and down instead of left and right. Okay. To find average velocity over a time interval, divide the change in what by the change in time?
Distance.
What does everybody else think? I'm going to rule out velocity. A lot of you saying find average velocity, you would do velocity minus velocity over time minus time. That doesn't make sense. Probably the best word to go here would just be position. It would be your x of t or x of whatever number that is.
I thought distance was position.
It is, but that's why I'm using this word. Because distance, like, here's the deal. If your initial position is 2, then after 5 seconds, you know, do you add the 2, do you not add the 2? If we're always talking about position, then it's clear what you're doing.
That makes sense.
Whereas distance could be just how far you travel. And we're going to continue this conversation. That's a good question. All right. And average velocity, that would be a rock. So pretty much when you're doing that, it looks like you're just finding the slope. All right, approximate, average, you're just going to do the slope between 2 points. And that's going to be, you know, not as accurate as the next one, which is instantaneous velocity. And what did you guys put in this blank? Specific, exact. I'm just going to write 1. All of those are fine. Precise, singular, okay. And this would look like the derivative. And this would have to do with 1 point. Okay, it's the whole difference between secant lines versus tangent lines, A rock versus I rock. It's all that same stuff that we've been talking about since the first day of school. Okay, acceleration. If the acceleration is positive, then what? Velocity is increasing. And then likewise, or on the flip side, if acceleration is negative, then the velocity is decreasing. If you ever get confused about this stuff, just think about when you're driving your car. If acceleration is positive, if you're pushing down on the gas pedal, what's increasing? Your position could be increasing, depending on which direction you're going, Velocity, though, is going to be increasing. All right. In order for a particle to change direction, what must change signs? Velocity. And it's important here that you really say change signs. When v equals 0, when velocity is 0, you may not be changing directions. A good example of this is when you stop at a stop sign. You stop and you keep going forward most of the time. Sometimes you turn, but you rarely stop at a stop sign and then reverse. That's rare. Hopefully it's rare. Okay, so let's look at this one. Find the total distance traveled. Now, I'm going to kind of talk a little bit about the longer way to do this, because if you don't have a calculator, and then I'm going to talk about the shortcut with the calculator, okay? So total distance traveled, okay? So what I want to do here is, to find total distance traveled, we can't just look at position, all right? We have to really look at velocity. And in fact, what we want to do is, first of all, we want to find velocity, which is easy to do without a calculator. That would be, and I'm going to go through this part pretty quick because we've already practiced this. So there's velocity, which was just x prime of t, okay? And I am going to graph this. All right. So how would you graph this by hand? It is a parabola. We know it has a -3, and it looks something like this. Okay, you're only going to deal with positive values of t. Okay, all the other stuff can be negative, but t is going to be positive. So you could have graphed this on your own if you needed to. All right, and this is v of t. So the total distance traveled has to do with integrating v. Okay, adding up all of this area. Now, this area itself is positive, and this area is, this area down here is negative, this area up here is positive, and if I were just to integrate from 0 to 6, my calculator, or if I did this just by integrating 0 to 6, my calculator or my brain would just say, this is negative, this is positive, and I would be subtracting those two values, right? But when you see this total distance traveled, that's not what they're asking. They're not asking us, what is the net displacement? If you want to use the word displacement, here it would be, how far are you from where you started? That's what you would get if you just integrated velocity. If you just integrated velocity 0 to 6, you would get the net displacement. You would get how far is this particle from where it started, okay? If I want the total distance traveled, in other words, I want to know what, like if you're in a car, your odometer, like whether you're going to home, away from home, you know, how far you actually traveled, your odometer. We want all of this to be considered positive. So like, in other words, I want this to happen. I want that to be positive instead. So to do this by hand, what you would have to do is find the 0 right here. Could you find where this equals 0? Could you do that by hand?
Yeah.
You set it equal to 0, factor it, you could find that. That's not that hard to do, okay? We're not going to, I'm kind of talking this out, but we're not going to do all that. And then you'd have to break this up into an integral from here to here, where you would get a negative answer and you'd make that positive, and then you do the integral for the second piece. Okay, this is how you do all this by hand. But if we have a calculator, which on most of these problems, almost all of them, you're going to have a calculator on this. Okay, there's only one little thing you have to do, absolute value. And we have done this before on after parties. So total distance traveled, you need to know, hey, that is just integrating the velocity, the absolute value of the velocity. If you just want to know how much distance, how far you are from where you started, you don't need the absolute value. That's an easier problem. All right, so what we're going to do is do this in our calculator. So in the home screen, I'm going to integrate. And then do y'all remember how to get absolute value? Catalog, and it's the very first thing. And then I'm going to type in, and you can use X here. Whoops. You can use X or T. Dang it. Why do I keep doing that? Okay. erase, catalog. Oh, because I'm at the T's because I messed up. All right, so if you're, this is good kind of to know, if you're stuck like not in the A's on the catalog, if you do alpha A, wait, hold on, I didn't do it right. There we go. It skips back to the A's, or you could have just scrolled up. This is the default though, and then I'm going to do T squared minus 2T, and then minus 3. Make sure you close the parentheses around the absolute value. Then we're going to do comma T, and again, I could be using X's here. As long as you use the same variable, it doesn't matter which one you use. And then you have to put in your bounds, comma 0, comma 6. This whole absolute value, you can only do this with bounds. You cannot do this just like in general. And I get 36, which is kind of weird that we get a whole number. All right, but it happens every now and then, especially when the problems are set up like this. Okay, does that make sense? Total distance traveled, you integrate absolute value of velocity. I don't think it's a good idea to memorize a whole bunch of this. I think you need to understand the concepts, but this is the one thing I want you to memorize. If it doesn't make sense, I want you just to memorize it. Okay, let's look at the next page. Here we have a table. All right, tabular, that just means table. Now, when we're doing these kinds of problems, they're either going to give you a table, give you a graph, or give you an equation. It is highly unlikely that they will give you more than one of those. They're just going to give you one. And so tables tend to be kind of the weird ones, and these are typically non-calculator problems, which actually means you don't have to do that much work, but you have to be really good at reading the table. So we have this velocity, we have all these times here, they're not going by even increments or anything, they're just certain times in velocity, and notice that my units here are meters and minutes. So we need to make sure we use that. We cannot do meters per second just because that's what we're used to. So at t equals 0, is the particle moving to the right or to the left? Well, how do we know?
Negative.
What's negative?
Velocity.
The velocity at 0 is -3, and you just read the table to find out. Okay? Negative.
So left will always be negative?
Yeah.
Left, down will both always be negative. When the velocity is negative. The position, acceleration, those don't have to be negative. All right, so moving to the left. All right, B, is there a time during this interval when the particle is at rest? Well, what did we say meant at rest? V equals 0. Now look at my table, and I do not see a 0. Does that mean the particle is never at rest? No, because I'm only given certain values. So can you deduce that V does equal 0? If so, where? Somewhere between these two. We have a negative velocity and we have a positive velocity. It has to happen where V equals 0 somewhere in between there. And in fact, it could happen many times. This thing could be doing who knows what in between these two values. And it could be equaling 0, velocity could be equaling 0 a million times, but I don't know that. All I do know is that my answer here is yes. And I'm going to say during 0 is less than or equal to t is less than or equal to 2, velocity changes from negative to positive. So V must equal 0. And there's always different ways to explain this. There are a few types of problems where they really want to see one thing, and I've kind of made a big deal out of it when we've done them. And we're about to have another one. So on part C, they ask us to approximate V prime of t. Okay, so V prime of t. Let's think about what they're really asking us. They're asking us for acceleration, an average acceleration, because I don't have an equation for velocity that I could take derivative of and plug in 10. That would be finding the acceleration at time equals 10. All right, so approximation means equals like this. So approximating a derivative, what they're really asking us for here is AROC, okay, average rate of change. Now remember, that's going to be slope. And we have all the information we needed here up on this table. Don't make it harder than it needs to be. Some of you want to do like a regression and find more values. No, all the numbers you need are on this table. So t equals 10 would fall in between 8 and 12. So I'm going to use, basically, I'm going to find the slope between those 2 points. Now you have to show this next step. All right, you have to say v of 12 minus v of 8 over 12 minus 8. You cannot just plug in the numbers or just write the answer. You got to do that. Okay, so that's going to be v of 12 is 5. V of 8 is 7. So this ends up being negative 2 over 4 or negative 1/2. And we need to use our units. So if you picked up that we're finding acceleration, then the units should be easy. It should be meters per minute squared. Okay, now here's another way I know my units. This is a fraction. I'm dividing two things. The top part is velocity, meters per minute. The bottom is minutes. So you could have written meters per minute. That would have been acceptable. That's not wrong. Or meters per minute squared. Here's the deal. On this one part, there's probably 3 points allotted for C. I believe there was. And one of them is for showing this step. One of them is for the answer with the right units. What this means is you get the right answer, but you get the wrong units, you don't get the point at all. All right, especially when it says indicate units of measure, you have to have that. All right, and then the last point would come from explain the meaning of this. Okay, so v prime of 10, we already said, is average acceleration. Now we do have to write out when it's average acceleration. So how would we say that? What are the restrictions on time? Yeah, from t equals 8 to t equals 12. And the point allotted for this explanation, they may not give you that point if you don't write from t equals 8 to t equals 12. You know, 1 point, there could be like multiple things that all have to be there to get that 1 point. So that's kind of a picky thing. They really want to see that. All right, for D, let A of t denote the acceleration. We could normally find the acceleration just by taking derivative, but with the table, it's not that simple. It says, is there a guaranteed time t equals c in the interval such that A of c equals 0? So I want you to look at the table, and I want you to think, is there a time for sure when acceleration equals 0? And if you can narrow down maybe where it would be, that's even better. First, just, is it yes or no? And like, if you take a cue from C, we found average acceleration, okay, by thinking about change in velocity over change in time. So the answer is yes. And now we have to explain or justify. So there's different ways to explain this. Anybody think they know one way? Put your thoughts into words. You can use some theorems here, but really, like, how did y'all know to say yes? Like, what was it that tipped you off?
It has to change signs, so it has to, V has to equal 3 at some points, it has to slow down to 0.
So what you're kind of getting at is that we have to look at not just the value of velocity, but whether velocity is increasing or decreasing.
Oh, if you cross 1 point, if 1 point is here, 1 point is here, and if you cross it, you're going to cross that line.
I mean, so this is kind of our clue. But I will tell you, even if 5 wasn't 5 again, let's say it was like 3, I would still know. So I'm going to tell you kind of what both of you guys said. At this 5, maybe that lots of stuff is happening, but at least somewhere between here and here, what is V doing?
0.
It's increasing. -3, 2, 3, 5, 7. It could be increasing and decreasing several times over. Like, again, I don't know what's happening in between. But it has to be increasing at least some of the time, right? Because these values are increasing. So I'm going to write V is increasing. If V is increasing, what does that tell me about my acceleration?
Positive.
The acceleration is positive. All right? Now, from 7 to 5, okay, and again, it could be decreasing, increasing, okay, but at least one time, at least some of the time, V is decreasing, which means acceleration is negative. And like what Brad was saying is, why did I say Brad? Do you have a brother named Brad? That's weird. Have I ever called you Brad this whole year? That just came out of the recesses of my mind. That's strange. Okay. Sometimes I do that with siblings. I don't know why. That's weird. Anyway, sorry. So here we have 5, and like what Brian was saying, you change from 5 to 5, or that value is, or what Crawford was saying. Do I get what I'm saying?
Yeah.
I feel like I'm like over-explaining it at this point. All right, so how could we explain this? Okay, V is increasing. So acceleration is positive. Then V is decreasing. And acceleration is negative. So A of C, they use this C, so I'm going to use it, equals 0 at least once. All right, the graph thing we're going to actually do tomorrow. I want you to turn now, and we have one more that we're going to do together. That one graph problem goes all the way through here. So let's look at 14. Analytic. This just means you're given the equation. This is the one most students are the most comfortable with. So I'm going to kind of go through this one a little bit faster. So we have x of t. That's position. It might do you good to go ahead and write that. They tell us that as well. So A, at t equals 0, is the particle moving to the right or to the left? You notice this question comes up a lot. And this is a really easy question if you just know what you're doing. And out of 9 points, that's a guaranteed point, or 2 if you can explain it. And so these are the points that you should always be getting right. I am not, by the way, expecting you guys to get all 9. Okay, if you can consistently get 4 to 5 points on these on your own, you're in great shape. I don't mean barely passing. I mean, you're at 4 or even 5 if you're also decent at multiple choice. All right, so the first 2 parts are usually easier. Then the last 2 parts get a little bit harder. Sometimes there's 5 parts. It just depends, but they're always worth 9 points. All right, so A says that t equals 0 is the particle moving to the left or right. Okay, how do you know?
Because velocity is constant.
And what is velocity? We need to show this. So the velocity is the derivative, right?
Yeah.
So I'm going to say v of t equals x prime of t. I need to show how I'm getting velocity. And then that's just the derivative. 3t squared minus 12t plus 9. Okay? And I can find the velocity at time 0 by plugging in 0. They're not going to really have, the AP test isn't really going to take off if you don't show every single little calculation. Like, this is an easy calculation to do. You wouldn't have to show the actual plugging in of 0. This is kind of obvious. And that's positive. So particle is moving to the right because v of 0 is positive. Okay, so there's a point, or maybe there's 2. I don't remember on this one. So B says that t equals 1 is the velocity of the particle increasing or decreasing. Now it's talking about acceleration. So I need to go ahead and find acceleration. A of t, which is going to be the second derivative, is 6t minus 12. And if I'm saying, is the velocity of the particle increasing or decreasing, I just need to plug in 1. Notice that they changed the value, so I need to do a of 1, which would be 6 minus 12, which is negative 6. So what's the answer? Decreasing. Because a of 1 is negative. Alright, C, find all the values for which the particle is moving to the left. This actually has more to do with part A. Okay, particle is moving to the left when V is negative. So how am I going to find all the values where V is negative? I need to make this a little better. So how am I going to find all the values where V is negative? What do I need to do first? I mean, forget about velocity for a second. How do you find out when a function is decreasing or increasing? You find its first derivative, and then you do what? You find the critical points, which is where the first derivative is equal to 0. So I'm going to go ahead and write here. I want to find out where v of t is negative. So that means I need to set my velocity equal to 0. And that's not all I need to do, but that's the first step. Now, this is a non-calculator. This could be calculator or not calculator. All right, but we could do this part without because this factors quite nicely. If you factor out the 3 first. This is why I've changed to a thinner pen to try to fit all this in one line. And so what are my 2 critical points?
1 and 3.
1 and 3. This is when velocity is equal to 0. This is probably where the particle is changing directions, okay? And so I need to actually put these on a number line and test them. So we're plugging them into velocity. So I take a number, it's just where you take a number, you plug it in, plug positive or negative. So 0, if I plug 0 into velocity, we already answered that on A.
Positive.
Okay, that's plus. So this particle is moving to the right. Okay, what about if you plugged in 2? There's a little bit more calculation. Negative. And if they typically flip-flop. So if you're not sure, that's what I would go with. We plug in a number bigger than 3, I get a positive velocity, and again, particles moving to the right. Okay, so this is what I want to look at right here. Okay, 1, 2, 3. You could put brackets here, but really, I think parentheses are always better. Because at 1 and 3, it's not moving to the left or right. Okay, but sometimes you'll see brackets with these. It doesn't ask me to explain, but if it did, what would you want to say? Because what?
The particle is moving to the left from 2 to 3 because position. Because the velocity is negative.
Because the velocity is negative, right. All right, now look at the very last part. Okay, total distance traveled. Remember how I told you there was a way to do that other one by hand? I think I'm going to talk more about this again tomorrow. But I would like for you right now to go ahead and do this one on your calculator. This is an easier one than the one I showed you to do by hand, by the way, because it's a simpler equation. So go ahead and use your calculator. And remember, this is what we're doing here. Sure. thinking really hard on this one. Nope, it did not do it. Did I do that right? Did y'all do it?
Yeah.
Okay, I'm gonna end the video. Stay tuned tomorrow.